In today's class, let us see about the curve representations. Okay, so in this we have different types of curves. One is the Bezier curve, then Nernst curve, NURBS. Then we have B-spline, okay, and Hermit's curve, right? So like this, we have different types of curve representations, and subsequently for that, we have the mathematical equations through which the curves are going to be represented, and it is going to follow that particular path for every value, and the curve is going to be generated. So before going to this, the curves can be generally classified into we can classify the curves in different varieties, whether what are the type of curve and mathematical equation it is going to follow. So they will fall under these categories. One is the implicit curves. Then we have explicit curves. And then we have parametric curves. Right? Okay. So we have like this. So what is this implicit curves, explicit curves, and all? Right? So here what will happen is that we will always have the for implicit curves, we will have it with a function, okay, where x comma y will be equal to 0. Okay. So here we will always have a function related to x comma y values, okay, based on which the curves are going to be represented. So they will have these functions in the mathematical equation. Okay. But whereas in explicit curves, it will be in a different form, this, where y is going to be a function dependent on the x value, right? Okay. So here the function itself for both x and y is going to be a function of x and y, the curve equation. But here x is going to be an independent value and y is going to be a dependent value based on the function of f of x, based on the type of equation for the x value. So based on that, the y value is going to be varied. Then the next thing that we have is that for parametric curves, okay, it is just going to be like this. Say for example, it is going to be like this, right, where the entire thing of the parametric curve can be represented as, okay, the x comma y values, okay, the x comma y values, right, where this will also be in the range of the points. We'll see this in the later stage. This will be varying from 0 to 1. That means from 0 to 100%. Okay, right. So within whatever is the size of the max 0 and maximum values for the x and y that can be incorporated for the parametric curve equations, which is that. So these have the parametric values based on, that is nothing but the x, y, and z values. Okay, right. So that is the different types of classification in which the curves can be is going to come under. It will fall in any one of these categories, right? Okay, right. So the next thing is that we shall see about the Bezier curve. The first type is going to be the Bezier curve, right? So in the Bezier curve, what is going to happen is that now what we have done as of now to represent, before going to Bezier curve, okay, I'll just take about this. So say for example, one is that we have straight lines, right? Okay, then we can make this into a square or a rectangle, right? Okay, so an upgradation of straight lines, no problem, right? So then we have the circle, right? So either we can take it as an arc, right? Okay, and then so circle, it's going to have a radius, then it's going to have the what the mathematical equations for that, right? So conversion of linear into circular form. Okay, a part of this, if we take, is going to be the arc. Again, it's going to be under the same thing, but only thing is that what is the starting and ending angle for this is the required thing that we need, right? Okay, then what else we have? Then if we go to the other thing is that it's not going to be a complete circle, so radius is not going to be constant. It is going to vary along the major and minor axis. So we will have an ellipse, so the radius is not going to be constant. So mathematical form for this is going to be different. Now apart from this, the next thing is going to be something like this, a curve. Okay, it has no constant radius, it has no constant coordinates, right? I mean, getting it from the datum point, right? So it is going to continuously vary. Now the thing that we have to understand is that now all these things are written on a 2D sheet. Okay, a line is a 1D diagram, a square or a rectangle is a 2D diagram, right? Then a circle is again a 2D diagram, right? Ellipse is also a 2D diagram, right? Now all these things are okay. Now when it comes to curves, the first thing that we will be noticing is that we can have a curve is actually a 1D thing. Okay, it's going to have a 1D because it is all we can do is that we can have the uh, length of the curve, but there is constant change in the its values, angle, and so on. So if you look at this, okay, if you take about over here, so it is going to be coming into picture over here. So this is a simple curve which has got only, it's going to travel like a sinusoidal wave in the x-axis. So it looks like, okay, it's going to be 1D where the sheet is also going to be 1D. Okay, its representation is easier. Now, if we take a look at this, then, okay, then what we can have is that it is going to have different views where we can also have such type of curves on a 2D sheet representing either a 2D space or a 3D space, right? So if you look at the geometric modeling and all, we are able to draw the curved features and all with on a 2D sheet by using only curves, so that it appears like a 3D diagram, right? So the curves are going to come into picture like that. So it is because of the nature of the way in which the curve has been drawn to represent a 3D. Yeah, so that is one thing that we have. Now going on to the Bezier curve. Okay, now let us just simple let us understand this Bezier curve. So what we are going to do is that to draw a curve, usually what we'll do if we want to draw a tangent, say for example, if we have a rectangle, okay, we want to draw a tangent circle. So we can take all the midpoints of all of them and we can connect it. If it is a square, it's easier, right? If it's a rectangle, then we'll get an ellipse, right? Because the length and the width is going to be different. Now, say for example, if we have an x and y and we want to draw a tangent to these, yes, we can draw that, right? Like this tangential right? Or even if we have an arc, we want to draw a tangent for this point, okay, we can draw it, right? Okay, so like this. Now, with this concept, what is being done in the Bezier curve is that, say for example, if it is a straight line, there is the end points, okay. Now, if you draw the line, it is going to be exactly on this path itself, okay, and there's not going to be any deviation, okay, right? So the tangent, the line, everything falls onto this itself. Now, say for example, if we have the end points, that is two lines like this intersecting, and we want to draw a curve for this, then what is going to happen is that we have to go for the tangential for both these things and come like this. Okay, so we have a curve like this, sorry, three points within which the curve has to be represented. Then the only way that we can do is that, okay, we will have to go in like this, tangent to both these lines, tangent to this line and tangent to this line also. But how is it actually happening is the question over here. Okay, so what they are going to do is that, now how this is going to come into picture, let us see. So the first thing is that we have the control points 1, 2 and 3. So we have the control points. Okay, let me draw the line. Okay, sorry, the line is not equal. Okay, now what we are going to do is that, if between point 1 and 2, if I'm going to go for one division, then between 2 and 3 also we are going to go for one division to convert this straight lines into a curve format within this region of space between 1, 2 and 3. Now, so what is going to happen? It is over here and here. The point is now shifted. Let us just assume like this. So it is like this. Now, if the okay, let it be here. Now I'll just change the color. Okay, now from here further on, it goes for the next incremental distance. Now if we connect these 2 points, it's going to be like this. Now it is going to go for the next incremental point. Then here, right? And we'll proceed like that for the next incremental distance. So look at these straight lines that has been drawn in purple, red, yellow, and green. They're constantly changing their angle, right? So we have one intersection point over here, then one over here, then one over here, and here. So now for this, we have to draw the tangents for these points. So what is ultimately going to go is that the curve is not going to go into this particular space at all. It is not going to go into this particular space anymore. So the curve for all these incremental values, it has to lie only within this boundary, right? So the curve is going to gradually take a turn over here itself, right? It's going to take a turn over here itself. So if I just draw this line, so the curve is just going to take a turn over here itself. So that's because for every incremental distance, okay, the tangential should be drawn at every instant of time. So what is going to happen at the end of this? It is going to happen like this, right? So that is how ultimately what we are going to get for this thing, this particular thing, is that if we have it this, then the curve is going to be like this, well within the points 1 and 2 and 3. Right? It is not going to extend till here and go about like this. It's going to be well within there itself, depending upon the Bezier equation. We'll see that equation in the later stage. So this is what is going to happen in the Bezier curve in a step-by-step manner. Okay, right. So, okay, so just a minute. I'll show you one more. Okay. So, yes. Yes. So here, what we need actually is that we are going to have, now let us see for only for first 2 points where we have point P0 and P1, okay, having x 100 and y 500 coordinate, P1 x 600 and y 200 coordinate, okay, right? So we'll see for this, okay, what is going to happen over here for a Bezier curve. So for every incremental value, because there's only one, there are only 2 points and it has to be connected, right? So there is no need of any flexible line, if you assume, to be bending in between in this path over here. There is only 2 points, so there is no need of this line to bend anywhere. It can be connected straight away as a straight line. Okay, so this is the controlling limit between 0 to 1, which is the which is represented by t, whose range will vary from 0 to 1, right? Okay. So now what is going to happen is that, now say for example we are going to have one more point P2 having a coordinate x 1000 and y 400. Now we totally have 1, 2 and 3, right? Okay, so for this what is going to happen, the t value should range from 0 to 1. That means from starting to ending, okay, this is going to be the 0 and this is going to be the 100% of the completion of the path in a flexible manner, right? Okay, right. So for this, how does it going to vary, we'll see, right? Okay, so now the first thing is that we can connect it by a straight line from P0 to P1 and P1 to P2, but that is only a straight line which is 2 different lines. We want it in a flexible line. Now if you take up the incremental distances, now as I just said just now, okay, when we take an incremental distance, okay, when we take an incremental distance, yes, it's going to go in this is for one incremental distance. So the incremental distance is going to travel by 150 and 400 in x and y, and similarly it's going to start from here also, because these two, there is one line from P0 to P1 and P1 to P2 is the another line that has to be connected. So for every incremental distance displaced over here, the other end is also going to be displaced. Now if you look at this, the new value is going to be over here, and if we connect this, it's going to be like this. Okay, right. So now let us continue with this. For the next incremental value, now just take a look at this. Now where is this after 2 or 3 more iterations? It is going to go here, right? So this has to be taking an intersection point here itself, right? So anymore the curve cannot pass beyond this, because here itself is the limit. It's continuously changing. So if we have to draw a tangent for this, then it's going to be tangent to this line, and for this, and for the next preceding one, we will see this in the next step. This is the next incremental value. Look at this. So we have, as it moves, okay, as it moves, this is the next incremental distance. So see here, it's going to end here, 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 and finally it's going to come up over here, right? So the curve, when we start drawing tangent, is going to be only with this, right? So let's see that. So it is going to happen like this. So ultimately, we are going to have the tangents drawn like this. So I'll just remove these points, so the red lines, so that you can clearly see how it is happening in a stepwise manner. Yes. So what they have drawn over here is for after every incremental distance, how the angle of the line is changing. So previously, when we had 2 points, it was only over here as a straight line, this particular one. When it is moved for one incremental distance, so this point has moved here and this point has moved here. So when we start connecting, it's going to be on this particular line over here. It's going to be here. For the next incremental point, the point is shifted here and from here to here. So when we connect this, we are going to get this particular line, right? So like this is the small changes that is happening for every value of the control points that we are doing. Right? So ultimately when it moves, yes. So after completely reaching from P0 to P1, right? And from P2 to P1 to P2, right? Now see what is going to happen is that we are going to have this particular curve that is going to be formed automatically, right? So when we break this into smaller functions. So if you look at this, what is there actually in the curve is that there will be a constant change in its coordinates x, y, and z, and its angle, right? It's not going to be a constant like a radius of a circle and just having the cos theta and sin theta values to be same for drawing the circumference of a circle. It's going to change continuously. So like that, for a curve also it is going to be here, but whereas in a circle it's almost the same, right? So here the equations is going to be represented by breaking this smaller segments of this. Okay, so breaking this line into smaller segments, and continuously if we change the angle, okay, then only we are going to have a smooth curve that is to be developed. So that is the reason why we are going to take about this the smallest incremental values for this, so that we are going to have a smooth curve to be represented, right? A smooth curve to be represented. Now this is what is going to be happening in the Bezier curve as a graphical manner that we have to see. Now the next thing that I'll be coming upon is that the second thing is that the number of control points, the number of control points that is going to come up into picture. Now if I want the curve to be like this, then I need point number 1, point number 2, and I need a point number 3 just like this, so that the curve is going to be within this. Now if I need a curve like this, then 3 points is not enough. I need a starting point for the curve, I need an ending point for the curve, okay, and I need another point over here, okay, and probably another point over here. So okay, I'll just draw this in the other color, so that it's easy to identify. So we need the control points, and these 4 control points should be there in this particular manner only, then we are going to get a curve like this, right? So we know about, just now we just saw about these 3 control points. So we are going to get a curve like this. Now to get the curve in this particular manner, we need the control points here, here, and here. So nothing but point number 2, 3, and 4. So point number 3 is going to be below here. So then we'll get a curve like this. So that is why we have this particular portion, right? That is why this particular point is below here. So ultimately, when we join this, one half is what? Over here is this portion. The other half is in the other way, like this. So this is what the curve that we just needed. So we need to have the control points 1, 2, 3, and 4, right? So that we get a curve like this. And this is going to take care of how the curve is going to change its shape. So these points, that is point number 2 and point number 3 in this case, are going to be the control points for defining the curve. Now, in all these cases, if you just look at this, how many of our points are there totally on a curve? Okay, the first point and the last point of the curve of the point will be always on the curve itself, or the curve will start on this first and the last point. There is no change in it. Okay, the intermediate points, okay, the intermediate points, that is P2, P3, P4, and so on, which is in between, is going to take care of the shape of the curve. So if I just displace this point, then the shape of the curve is going to be changed also. So what does this indicate is that based on the position of this point, the shape of the curve is going to vary, right? That means that is the reason why these intermediate points are called as the control points. So just by moving the intermediate points, we can change the shape of the curve, okay, which is a very, very important feature. Yeah. So we'll just see this video now. Yes, the first line, first incremental distance, second. So just they're just tracking with the, we can see it in slow motion over here in a stepwise manner. Okay, in a stepwise manner over here. First a straight line over here. Okay, without at t equal to 0. Okay. Yes, at first incremental point, the line of the angle of the line is going to change, right? So it's going to be over here. So this the red dot is nothing but tracing the change in the angle of the line. Okay. Yes, for the next distance. Okay, so just for the next distance, for the next incremental value, see here there's a change, right? Because the angle of this line has changed after the next incremental. And then for the third step, so this line is changed, so the curve cannot get extended. Okay, and based on, there's one more method also. There's one more thing that we have to comment that I have not spoken about, is about the weightage of the points. Okay, so based on that, it is going to change its path at every incremental distance. So in the next step, this is the point, I mean this is the line, and the tangential weighted method is going to be over here. So subsequently, this is what is going to happen. So thereby we are going to get this curve automatically, and this is going to be the overall control point for this curve. Okay, so this is the start and end, so 0 to 1, right? So it's from 0 to 1. So we can also see the percentage over here. Okay, the time limit for this. Okay, from 0 to 1. So 0.1, right? 0.2, that is the next step. T equal to 0.3, that is 30%. Okay, so if we look at this, the 30% from the starting point, remaining 70% it has to move to reach its end value. 40%, 50, 60, 70, 80, and 90, and finally 100. That is nothing but t equal to 1. So it is going to always vary from 0 to 1. And ultimately, when we trace this, this is how the curve is going to be coming into picture, right? So this is about this is how it actually happens when this mathematical equation is going to be used. The changes are going to take place in a sequential manner, and the curve is going to be generated. Okay, right. So now let us see about, now just look at this. The end, starting and end point is not changed. Only this control point has been shifted from here to here. So automatically what is going to happen is that the curve shape is going to change, right? The curve shape is going to change. Yes, this is about the writing of the equation for the Bezier curve, which we'll see in the later on stage. Yes. So now coming back to this, so in this case, now we have 4 control points, sorry, totally 4 points, 2 control points. Okay. So we will be, so what is there? If we take up point number 1, 2, and 3, then the curve is going to be like this. Then if you take the next set, okay, point 2, 3, and 4, okay, if you take the next set, you draw the curve for this, it is going to be somewhere from here. So ultimately when we join this, it's going to be like this, right? Okay, when we combine these 2 parts, okay, the curve, the overall curve has to be like this. So we'll see that now. Okay, so just in the first step, we have the first line, okay, the first incremental distance and second incremental distance over here, okay, and similarly over here, this particular line is also going to go for one particular incremental distance and subsequently, right? So just look at this, how is it traveling? So within these points 1, 2, and 3, we have the line incremental for every incremental distance, it has been traveled over here, and a trajectory path over here. And similarly, a trajectory path has to follow over here also. But here itself, this line has started to deviate. So the tracing point is not going to be anymore over here. It has to be here on this particular line, right? So as it gets deviated, so here it just crosses like this, almost like if you just trace this blue color dot over here, replay it. Yes, so the curve is going to go in a sequential manner over here, and it's going to start deviating here itself. So see, this blue color dot starts taking a turn here itself, right? It's not going to go up to here, up to this end, and then. So it has to draw a tangential line between these particular path and this particular path, which has to be in a continuous manner. Okay. So if you look at this red color line, which is going to be the ultimate Bezier curve for these 4 points. So here itself, it's going to take a twist and it's going to take a turn ultimately into the opposite direction. Right? So if we have to represent the curve based on the shape of it, depending upon that, the number of control points are also required. Okay. So anyway, this is about the programming based on the mathematical equation that has to be written. We'll see that in the next class.